Okay, so when you're looking at two objects, and I'm going to tell you that they are similar to each other. Okay, so if they are similar, we have to do our matching side, which are corresponding, is the word. Okay, so for instance, if I take this side of 5, which one would it correspond to? 7. Okay, I would have used this. It is located across the one swivel, so which one over here is located across the one swivel? Okay, now I'm going to do the 18. Which one would my 18 correspond to on the other triangle? X. Okay, well that makes it easy, right, for the last one. So now I'm going to set up a 4-part ratio. Ratios always have 4 parts. Something over something equals something over something. Okay? What is the one partnership that I have to use? You have to use 7 and 5. So I'm going to do 7 over 5. So I'm going to go like this. This is the right triangle, and this is my left triangle, or whatever. Okay, so I called it, this is the triangle that's on my right-hand side, and this is the triangle on my left-hand side. So I have to match that pattern. So what is the same ratio? And you're going to do one thing at a time. So what do you want me to do? Do you want me to do my pinks or my blue? Pink. Okay, so there's an X and there's an 18. So which way do I have to write it? X18 or 18X? X and 18, because you have to follow the same proportion. So if I did my right triangle divided by the left, right divided by left. Okay, when I go to type in my calculator, you always connect diagonally, something times something. So that would be which connection? 7 times 18 and divide by 5. Okay, redo. We're going to go all again, and I'm going to keep 7 over 5. I'm going to keep that ratio because that's the thing I knew. So now, we just did our pink, so I'm going to connect my blue. So do I want y over 27 or do I want 27 over y? 27 over y, because I have to keep it always the same. So proportions get solved, something times something divided by something. What is it going to go in this case? 5 times 27 divided by 7. $19.29, and yeah, that was rounded. Okay, so what if I asked you about scale factors, or what if I've asked you about similarity? Oh, you're way ahead of me. Okay, so to get a scale factor or to understand the similar, you have to understand the proportions of the sides. So 7 to 5 was the first matchup. We've had another matchup now, which would be 25.2 to 18. And we've had the other matchup, which is 27 to 19.29. Okay, and if we've done this correctly, these should all be the same, right? Because I told you that it was similar. I told you that it was similar, so you can see this. This is called, this number here is called a scale factor. 1.4, is that bigger than 1? Yes. Did my object get enlarged? Yes. Okay. So if I had drawn this the other way around, what would have been my scale factor? Instead? No, you can't have negative scale factors. You would do it the other way around. 0.71 would have been your scale factor. Okay? Got it? Or I would have just done it the other way around. 5 divided by 7 shows me, does this make sense? Because it's underneath 1. It's lower than 1. Okay, we're going to go to the second question, so I'm going to pause for you to draw it. Maybe it wasn't supposed to be there. Okay, so here's what I know. When I'm doing similar objects, I always need 2 objects. Okay, so we're going to do that. We're going to draw 2 objects. Okay, so here is my first object. A triangle like that. So I'm going to go 3, 7, and Y. I'm going to draw it over here. Now, can you see the second triangle? Here, here, and here is a second object. So I'm going to go 10. Ooh, what should I put on the bottom? 7 plus x. The bottom of that is the 7 part and the x part added together. So then this would say y plus 14. Okay, so now what am I going to do? I'm going to look for my matchups, those corresponding parts. So the 3 on this would correspond to the 10 on this. The y on this would correspond to the y plus 14. And the 7 on this would correspond to the 7 plus x on that. We good? Understanding the 2 objects, the corresponding pieces of matching. I'm going to start a ratio, which is going to have something, something equal to something, something. Right? The 4 parts. Always 4 parts. What's your first instinct going to use? 10 and 3. How do you want me to go? Do you want me to do the 3-10 or the 10-3? It doesn't matter as long as you keep the same flow. So somebody else could have done 3 and 10 as long as they're making the other one the same. Okay, so I did this 10 to this 3, and I'm trying to solve for x. So now the what over the what matchup? 7 plus x over 7. Do you see?
I just have a question. If it would be possible to, like, do Pythagorean theorem to
Nope.
find
Do you know that this is a right triangle? Have you been told it's been a right triangle?
No.
Never know.
No.
Wait, will you ever, if it does say it's a right triangle?
If I do, then I do this in the corner. It looks like 1. What if it's 89.5 degrees?
What if it's 89.9999999?
Okay? So that is a mistake in math that's common, is that people make that assumption. You can never use Pythagorean theorem unless this is the only way you can activate Pythagorean theorem. Okay, so yes, oh, it looks like it, but you don't know. Is it 89.5 degrees? I don't know. Okay, now here's my proportion. So what do we always do? Something times something divided by something. So what am I going to do? Times divide. So 10 times 7 divided by 3 would normally equal blah, this. But I don't just have x, I have. So normally that's just your answer, but I don't just have a question mark there. I have a 7 plus x there. Does that make sense? Yeah. You're always way ahead of me here. I haven't even done that. Okay, what do we got? 7 times 10 divided by 3 is 23 and a third. Subtract 7. Okay, does that make sense? So I had a few things that I did. I broke it down into 2 shapes to make my correspondings. And I just understood that this divided by this, yeah, it's that position, but I don't just have one thing to consider there.